Welcome everybody to my talk about innovative customer-specific heating and sensing solutions. My name is Stefan and I studied chemistry at the University of Constance and did afterwards a PhD dealing with nucleation and crystallization theory. And I joined IST 1.5 years ago, and I am now responsible as a team leader for new thick film products within the IST. Let me introduce the innovative sensor technology briefly. We are founded in 1991 and our headquarters in Ebnat-Kappel, which you can see on the right. It's in the beautiful valley of the Toggenburg, and we are leading in tailor-made sensor solution. I will explain you later what we understand by that. We are a partner of renowned universities and institutes like the ETH or the University of Applied Science in Munich. We have multiple production sites to enable contingency for our customers, and of course we have worldwide sales offices to support you in any case. What do we offer to our customers? We have physical, chemical and biological sensors. You can see a selection here, so we have temperature sensors, mainly PT100, PT1000, nickel sensors. That's what we are, I would say, famous for. But we also provide you flow sensors, humidity sensors, conductivity, biological sensors for the measuring of glucose and lactate, for example. Now, newly, I would introduce them to you later. We also offer you heater solutions, and we understand ourselves as your technology partner. What does that mean, technology partner? So we offer you individual sensor designs, so we offer you distinct or different resistance values. You can order a sensor as an SMD device or wired, as you can see on the left here. Of course, the dimension of the sensor are up to you, and the choice of materials as well. But of course, we will support you in these decisions. We also offer you customer-specific modules. For example, for the humidity sensors, we also offer you modules with an integrated calibration. And as you can see, for example, at the flow sensors here, we also have tailor-made housings. So how do you order or get your sensor tailor-made? So you as a customer here on the left side, you want to measure something, probably temperature or flow, or you want to heat up something, or you just have an idea what would be useful for you and you're not sure how to measure that. That's what you're dealing with, your issue is, and then IST will look in his toolbox with our R&D team to solve your challenge. We then normally have a first technical meeting, really an in-depth technical meeting where we need to understand your problem to find the perfect solution for you. After we define the task, we then start to develop the prototype. A prototype, of course, will be tested at IST, but of course also at your desired application to see how good we are already with this solution. So probably we already have an 80-20 approach to it, and in several improvement runs, we then come to the 100% solution. And then we start with a serial production for you. We are ramp-up experienced, so we can deliver you like probably 100 sensors per month. But if you demand 1 million sensors per month, that's also no problem for us. We have still the highest quality standards, as every sensor is checked electronically and optical. And if you demand special qualifications like the ESCC for the European Space Agency, we are also willingly to supply you with that. Let's check which toolbox the IST offers to you. So we already talked about the design phase, so where we understand your problem and try to figure out how we can deal best with it. Afterwards, the next step is to define which materials are used. We have different substrates available, most important one alumina and zirconia, but we also offer you, for example, sapphire, steel or alumina nitride, so we are very flexible in this case. As resistor materials, we have metals as standard one, most importantly of course platinum, but also tungsten or nickel or tantal, if you like. And of course we also offer you dielectrics, for example silicon nitride or tantal oxide, or some insulating glasses. Regarding the coating, we have the thin film technology, which the IST is famous for since the last 30 years, which has a high precision, relatively small thickness and a small line width. But we also have thick film devices here, or tools, which has the advantage that we are fast processes. But on the drawback on this is that the thickness of the coating is between 2 and 10 microns, and also the line width is normally bigger than 100 microns. After the coating, we go to the patterning. So we have photolithography, dry and wet etching, and laser trimming in the end to adjust the resistance to your desired needs. And finally, we have the assembly process with dicing, bonding, welding, whatever you demand. So today I would like to focus on thick film processes, and one example where all the IST expertise is combined is this conductivity sensor, which has a PT100 for temperature compensation here in the front, and thick film printed platinum electrodes. We have inert materials for applications in aggressive or contamination sensitive media, so for example biotechnology and medical devices is very sensitive to contaminations. We have a flexible geometry. We also can provide you a thick film only solution, which is of course price wise favorable, and a measurement regime between 10 microsiemens and 200 millisiemens. And for the application regime, for the different fields of application, we have biotechnology and medical, as mentioned before, but also automotive and process control. To show you one example where we act as a technology partner, I would like to introduce a level sensor to you. So none of these standard measurement principles is applied there. So it was really development, customer-specific development. And you can see it here on the right side with gold electrodes printed via thick film technology. And we have also the evaluation electronics developed and designed at the IST. We want to measure the level of coolant or a heating fluid at harsh environments. In this case, it's about 200 degrees Celsius and 16 bars. And one big problem in this case is that condensed water could lead to false measurement, and that's why we had this smart electrode design you see on the right. And also the electronics is programmed that we have an AC actuation to prevent the electrolysis. And of course applications, as I mentioned, is process control and automation, and to a distinct part also HVAC. As I mentioned before, we also offer now heater solutions to you. Therefore I would give you a short introduction to the IST's micro heaters with, of course, some advantages and some disadvantages. As the advantages, we have a low power consumption, it's a well-controlled temperature distribution across the heater. SMDs can integrate it very easily. So for example, if you want to solder a connector on top or a thermal fuse for security reasons, that's no problem. Materials are biocompatible and we can reach high temperatures. Inherent to our production process, we have this planar geometry, and therefore we also have non-flexible materials, so we are not providing you a polyimide heater, for example. And due to this non-flexibility of our substrate, we are susceptible to impact loading. And finally, the anisotropic heat distribution is in between the advantages and disadvantages, because of if you want to heat a distinct surface, it's favorable to have this anisotropic heat distribution, but of course if you want to have a homogeneous heating of a volume, you probably need more than one of these sensors. How they are made of are shown in the middle here. So we have a substrate, for example alumina, zirconia or aluminium nitride. We then print the metallic resistors, platinum where we are most experienced with, but we also can offer you some alloys like the silver palladium or other alloys. We can offer you various leads and pad materials. So for example, if your heated area should be far away from the electronics, we can print the leads to that. And finally, we end up with a glass passivation to prevent mechanical damage on the resistor track. And one example for such a heater you can see here on the right. It's completely made out of thick film technology. We have a small connector in here. It's in this case a platinum resistor. We have a huge resistance regime. Of course, we are limited by the size of our heater for the high resistance regimes. Size and geometry are flexible. And if you like to have an optimized geometry, we also can run simulations where we find the optimum between heat up times, temperature distribution, and mechanical strength of the heater. As I mentioned before, temperature range is up to 800 degrees Celsius. But if you request higher temperatures, of course, we would like to support you in this case. And as it's a screen printing technique, it's easier scalable. So if you require, for example, 1 million devices, we would be happy to support you with that. And applications are manifold, so biotechnology, process control, automotive, and medicine, which I show you later a short example of. All right, as I mentioned, I will also give you some insights into our research and development projects and actions. And one of these is a heater for medical applications. We have dimensions that fit into a medical cannula, and we have precise temperature profiles adjustable. We have inert biocompatible materials, and they have, as you can see here, really high aspect ratios. They can be used, for example, to destroy cancer cells during a surgery, and that's why they need to fit in this medical cannula to be supported by that, because you can imagine that's based on ceramics and they would easily break. Another project we are currently working on is this sensor here on the right. It's unfortunately, it's still under development. It's a pressure sensor which can be customized, and it's based on our inexpensive thick film technology with a high temperature solution, and that gives our customer the advantage that he has low assembly and packaging costs, because if you work with silicon-based pressure sensors, the housing of the sensor for harsh environments can make up of 95% of the cost of this sensor. And in the long term, we would like to have a direct temperature sensor on this pressure sensor as well, so we can get 2 parameters out of one sensor. Applications are, for example, in the HVAC, process control, or automotive. As we have a strong R&D department, we need some support from our metrology department, which I would like to introduce quickly to you as well. We have a large pool, finally, out of several techniques. We have imaging tools and chemical characterization. So, for example, here you can see our SEM electron microscope with an EDX detector to have surface characterization and the chemical composition. The XRF is also very useful for the chemical component analysis of thin coatings. We have some optical microscopes, and they are also supported with an automatical optical inspection for quality control. We also have non-destructive characterization methods, for example, this Xray 2D imaging and 3D computed tomography device on the right side. I will show you later what is the biggest advantage of that device. Of course, we have thermal testing, so we have this thermography setup here, where we can measure the heat up times, the power consumption, and the heat distribution of our heaters. We have pull and breakage tester to check the stability of heaters, but also the quality of our welding. We have layer and surface characterization tools. So we have an optical and tactile profilometry to measure the roughness and waviness of our surfaces. And of course, as we do the coating on these surfaces, that's a very important parameter for us. Optical reflectometry and XRF to determine coating thickness or layer thickness of the layers. And we can also prepare cross sections to have a closer look what's going inside of our sensors. And one example I show you here. We have this sensor which came back from our customer as a non-functional sensor, and you can see here the mold around this sensor was made by our customer, and during this molding process we could clearly see this fracture here, or this critical deformation caused finally to a fracture in the wire, and we could support our customer and giving him the advice to do his molding a little bit softer. On the right side you see a non-destructive quality control of the wire, so that's what the Xray tomography is really good at. So here you can see the pads and the wires and the welding, and now you can see the passivation on top of the welding, and here now comes the PT1000 meander with a substrate, and now we can have a cross section throughout the sensor and check the quality of every welding. So, and in this case, we see that the welding is sufficient for our quality expectations and that we can ship them to our customers. To summarize that shortly, we are the IST as your reliable partner. We have the thin film technology, which is the core competence for most of our sensor technologies. We have high precision and extremely high accuracy. We can offer you thick film technology, which is the core competence for our heaters, or most of our heaters. We have a broad application range, so for example, you can also think of ceramic PCBs. And we have the high volume production capability. We also offer you analytics as a service. So our metrology department supports us during the R&D projects, but are also happy to support you during the R&D project and offers you failure analysis of your post processes or further processes. And all this combined, we are a technology partner, customer focused. We really want to understand your problem and find the best solution for you. And if you like to go on a R&D journey with us, then you can just contact me or Patrick, who is the area sales manager in Germany. With that, I would like to thank you and happy to answer your questions.